Welcome! In this series of videos, we will look at the design of systems using the PowerBasic Windows and console compilers. Today, we will look at starting to design your new system for running on a cluster. Over on my hardware YouTube channel, I've been detailing the work done to create the computers that will be used in this cluster processing project. While there is a little more cosmetic work still needing to be completed on the Odroid computer rack, it is otherwise fully functional. But today we are going to talk about the approach to designing this software system. Up until now, we have looked at designing PowerBasic applications that run on a single computer, or accessing a database or website, either hosted locally on that single computer, or hosted remotely on another computer or server. But what we want to look at today is how to create a system where the work needing to be done can be shared amongst a number of computers without them getting in each other's way. Firstly, we will start with the database, where all the information in the system will be stored. While each computer may have a local cache of information during processing, the definitive golden source of information will be stored centrally in the database, allowing each machine to read from that source as and when it needs to. This database is held and accessed from the data computer. The database could be of any kind as long as it allows multiple computers to create, read, update, and delete information from it. Additionally, our data computer will also hold an archive, which will be a write once, read many times repository, which forms the audit trail for what has taken place in the system. In order to control and monitor the whole system, we need a monitoring process which decides what work needs to be parceled out to each of the worker computers in the cluster. It can do this by monitoring the database to see what work is needed and updating a table in the database from which the worker computers read their to-do list. By this method, there could be a very large number of worker computers in the active work pool as they only need to communicate with the database. The work pool is therefore very scalable and can grow or shrink as the need arises, simply by changing the number of computers. As the monitor processes may assign multiple tasks to each of the work computers, and each of those computers has multiple processing cores, there is no reason that tasks cannot be run in parallel. Running each task on a separate processor, or allowing Windows itself to sort out which processor processes the task, will increase the throughput of the whole system. Therefore, for a work computer with 4 processing cores, we can run up to 4 tasks simultaneously without overtaxing the work computer. So what do we need to put all of this together? Well, let's have a look at the data computer first. On this, we will host the database. In this case, I've gone for Microsoft SQL Server Express. This product does have several advantages. It's free, easy to install, and in addition, it can run on a modestly specified machine. We have also demonstrated in a previous video PowerBasic code to connect to SQL Server databases using the SQL Tools third-party add-on. Both the database and archive will need disk space, and in this case, I've gone with 12 2TB disk drives in a mirrored configuration, using only the software tools that come with Windows Pro. This should provide more than enough disk space for our project. Obviously, all of the computers need to communicate with each other, and a simple unmanaged gigabit switch with enough Ethernet ports makes that task simple. The monitoring process has several tasks to perform. The worker computer's status is read from the database, allowing the monitoring process to decide which computers to allocate tasks to. Displaying the status of the system as a whole will allow administrators to identify any computers with problems. The monitoring process should, however, automatically reallocate any tasks from computers that have become unresponsive. On each of the worker computers, I've decided on installing two software processes. The task service runs as a scheduled task which checks to make sure it has the latest version of the underlying task process. It also reports back to the database as tasks get completed, and launches one instance of the underlying task process for each processor it has, assuming that there are actually tasks allocated to the work computer. The launch task process actually performs the work, reading the details of the task from the database and writing out to the archive as it is processed and updating the database at the end of the task. The whole system is designed to be fault tolerant to cope with computers rebooting unexpectedly or becoming unresponsive, as well as new computers being added to the system. I personally tend to approach any programming project from a data perspective. What data is being stored? How are all the data elements connected? And only after that, how can they be presented and manipulated by those needing to get at the data? The SQL Server Management Studio allows you to lay out your database, showing the connections between tables which contain your data. But even before that, I use mind mapping tools to prototype what's in my head. Such mind mapping tools do allow you a three-dimensional view of your database, how it could look, and how the different parts of the database actually interact with each other. As you can tell from this diagram, I've already got a really good idea of how the different parts of the system are actually going to connect to each other. In our next video, we will actually start the coding. But that's it for today. Thank you for watching.